Hello, everyone. Just checking, I think I can hear my voice on the speakers. Can everyone hear okay? Cool. Okay, so morning. First of all, thank you very much for attending the 9 o'clock slot. We were worried about how many people would make it, so yeah, thanks so much and congratulations as well for making it at this time. So welcome to Magic Micro-frontends. So this is kind of a story of how we've used micro-frontends within our environment. So it's a pharmaceutical regulated environment, how we've used them to help improve some development practices and increase agility. So I'm James, and this is my colleague Nikola. So we work together at Sanofi.
So on the concept of Sanofi, to make also our bosses happy, let's give you briefly our digital mission. So what we want to do is we want to become a leading digital healthcare platform. So how do we want to do it? We want to change the practice of medicine by leveraging data and digital, and to create an inspiring work environment where we can empower people to be the best versions of themselves. So now that we've made them happy, we're going to continue with the presentation.
Cool. So first of all, maybe a quick show of hands actually. Who here works in a regulated industry, something like pharma or a few? Okay, cool. So we just wanted to kind of explain some of the general concepts, make sure everyone understands what we mean by that. So Sanofi is a pharmaceutical company, which is a really heavily regulated industry. So we're making medication, making drugs that could be injected or ingested by a patient. So obviously safety is critical for us. So we need to make sure that we make the same thing every time. And in our context, working as software developers, we need to make sure that any software systems related to those manufacturing processes, quality processes, work exactly as expected, and we can prove that they have worked as specified, etc., etc. So some other regulated industries, so automotive, aerospace, where clearly safety is really, really key. And another one, finance, so a different context, but where you need to be sure that everything is fully auditable, you know where the money is going, and everything works as expected and is fully traceable. So that's what we mean by regulated environments. In the pharmaceutical industry, just to give a little bit more context, we have this concept of GXP. So we're trying not to use acronyms too much, but we might accidentally refer to it during the presentation. So to explain that, the G and the P mean good practice, and the X is any kind of business domain or business process that we might be working with. So good manufacturing practice, GMP, for us, that's anything related to the manufacturing of medication. Good laboratory practice is how we work in the labs, how we're testing the products. And so we make software systems that interact with both of those processes, actually. So we have this concept of GXP regulations, and we refer to those systems which must follow those regulations as validated applications. So if you hear us in the presentation actually saying validation, validated, GXP, that's what we're talking about. So what are some of the constraints that we have within this industry? So let's say nothing, on the face of it, nothing special, nothing that you wouldn't expect in normal software development processes. So say we have the standards of good development practices, solid architecture. For us, the key thing and what we want to highlight in this presentation is what we need to prove to an auditor. So within these regulated industries, you could be audited at any time. And that means that you may need to present evidence of which version is deployed in production, or which version was deployed in production or official test environments 2 weeks ago, 3 weeks ago, 5 years ago. And you need to be able to show all of the approval chains. So did your quality assurance teams, technical owners, product owners, all approve the promotion to a test environment, then to another test environment, to a production environment? You need to show non-regression testing evidence, so things like screenshots and videos. Everything is really, really heavily controlled. So it's not a crazy idea that you should do non-regression testing or that you should know what is deployed to production, obviously. But the key thing for us is that this can add, depending on how your systems are architected and how your processes are designed, this can add a lot of administrative overhead. And so that's what we're here to talk about, how by redesigning the architecture of your systems, how can you potentially reduce some of that overhead? So let's go back a little bit in Sanofi to look at how we were designing our applications. So traditionally, we would build monolithic front ends. So what do we mean? We have, let's say, some specific business problems that we want to solve. So might be optimization of the release cycle for some medication. So speeding up the process for manufacturing or releasing some medication. This for us would be a single application, monolithic application. We might have another application, so application B, addressing a different business problem. These two are managed and built completely separately, and any change to those applications, so that let's assume they're both regulated apps, release of medication definitely would be. Any changes to those will go through a full change control process. So all of those approvals for promotion between environments, storing all of the testing evidence, non-regression testing for every single component of the app, every release, even if you didn't touch all of those components. And on a bit of further analysis, what we found as well, in addition to those heavy processes, is that actually, although these are specific business problems, we have a lot of contextual data which is interesting for users of both applications, so represented by the different symbols here. So what we found was that although we had separate applications, sometimes there were components or data which was being displayed which was really, really similar or exactly the same thing in a slightly different format between applications. So some duplication of code, slightly different user experience for looking at the same thing between applications. And then importantly for this presentation, more administrative overhead because you're validating the same thing twice or 3, 4, 5 times, depending on how many teams have implemented that. So with this in mind, what is it that we want to do and why are we talking about micro-frontends? So the mission for us really is reduce our administrative overhead, be more agile, so help us to release our regulated applications faster and also build them faster with more control, or maintaining the same level of control, I should say, and also, as a bonus, improve the user experience by trying to make some of those things more consistent between apps which are representing the same thing. Before we go into a technical demo that Nikola will lead, we'll look at a few of the principles, a general summary of what we mean when we talk about micro-frontends to make sure we're all on the same page. So let's say the general concept for us is applying the microservice paradigm to the user interface. So say that concept of small services instead of monolithic services, and using that as components within the UI. So for us, a micro-frontend, it's an independent section of your user interface, and it's built really for integration into other applications. So what our approach generally, as we'll talk about a bit more, is where we have things which are likely to be represented in more than one application, it's a candidate to be a micro-frontend. And so it's really things which are shared, where we're going to be reusing them, that we would try and build as a micro-frontend. It's an independent project. It means it has a separate build cycle, or build process, separate deployment. target and process. And that's really important, as we'll talk about, for us, because remember that concept of our really heavy admin processes on big builds. Here we're looking at how can we make that smaller, and by making the build smaller, how can we reduce some of that administrative overhead. And theoretically, you can use any UI framework for micro-frontend purists. It's not really recommended if you have 5 micro-frontends in your app that you have 5 different UI frameworks, but theoretically that is possible. And for us, it's kind of a natural progression. Just the 2 diagrams below that I took from a blog post, but which I think is titled "Why You Probably Don't Need to Use Micro-frontends," but but I like the pictures, so it's all good. So we're actually have already gone through the process of a very similar process on the back end of carving out sections of monolithic backends into reusable microservices. So here we're talking about the same concept in the front end, with the basic goal of reducing the size of our deployments and therefore the scope of the deployments, and therefore the amount of documentation that is required to go with each deployment. That's the fundamental goal of what we're trying to achieve. And I'm going to give you an overview of probably some of what we picked as the 3 kind of key concepts from the micro-frontend world. And then Nikola will do a bit of a technical demo for each of those to explain what we mean by them. So the first one should be, applications should be composable. So those shared components, that contextual data which is reused in our monolithic apps, we want to have a catalog of micro-frontends that developers or development teams can pick and choose from. So we need to have data X, Y, Z. We'll pull the components into our application, and multiple applications can do that. So by doing that, you're reusing the code. You're also building a more consistent user experience as well. Next one is around loose coupling, isolated applications. For us, the idea is really controlled communication between those applications which are integrated into a page. So the reason that's key for us is, so one micro-frontend is able to say, you can theoretically integrate me into any application, and that's safe to do, because I know that any data you send to me, I'm going to filter, I'm going to reject messages which are incorrectly formatted, etc. And the other concept of the loose coupling is to avoid those applications having to know about all of the other applications which are integrated on the page. So it's achieving controlled communication, but in a simple way without too much integration between apps. And the final one, which is really, really important to us, is the concept of them being independently deployable. So we need to be able to deploy one micro app, a change to one micro app, without having to change all of the other micro apps, or without having to change the integrating applications which are displaying them. And with that, I'll pass over to Nikola.
Thanks, James. Okay, so let me first kill a bit the presentation, and let's jump a bit into our UI. So those of you who have maybe seen our presentation in London earlier this year, we had a topic on the evolutionary architecture. Don't know why it died. Okay. On the topic of evolutionary architecture, there we had a small pitch from our millionaire boss, Elon Musk, that wanted us to fly to Mars. So let's say we achieved that goal during that presentation. So we're now taking it a step further, where we want to reach Saturn at this point. So for this, we've built an application which is aeronautical by nature. This means that parts of it should be GXP by nature. So the screen that you see in front of yourself is composed out of 3 micro-frontends. I'm going to enter more into details about each and every of these components a bit later. And the application also has 2 routes. So you have the main one, this is the dashboard one, and the second one, which is astronaut running in space. Let's call it a space view. Imagine that we have a drone that just sees something from the outside. So as I mentioned, this page also has 2 micro-frontends running here, and more on that in a second. So coming back to the presentation, let's talk a bit about the architecture. So in Sanofi, we're quite proud that we're sponsoring some open source projects. So for this coding demo, I hope that it comes back. For this coding demo, we used Vue.js, which we sponsor, and we used Single SPA, which is a framework how you can build your micro-frontends. There are many others on the market. It's just the one that we selected for this demo. So as I mentioned, first we have on the dashboard, I said we have 3 micro-frontends, and on the space page we have 2. So the architecture of a single SPA application is quite straightforward. You have a single root config application. That root config application is nothing else than an entry HTML file which registers your micro-frontend applications, so which I'm going to elaborate in a minute. And it only exists to create the application, so you shouldn't put any logic in it. It should be like a simple bootstrap file. So what is an application in the concept of a single SPA? So it's the same as the single page application. The only difference being is that it doesn't have an HTML file. I mean, you can have the template files if you're using Angular or something, but still, it doesn't have any HTML file that it builds. And you can have as many registered applications in your root config as you would like. We just selected 2 to make it quite simple. And important concept of an application, since it's being registered, I'm going to show you a code demo in a second. The application by nature is declarative, and it should be lazily loaded, so it shouldn't be automatically loaded on the bootstrap of the project. It should load on a specific activity. So, or in a single SPA world, we call this process mounting. So it shouldn't exist until it's being specifically called upon. And the last concept, and to be honest, our favorite, is the concept of parcels, which you could have seen maybe on the dashboard, but more on that a bit later. So a concept of a parcel, it's similar to the application by nature, the main difference being that parcel is imperative by nature. That means it's called upon when you need it from your own UI. You don't call it upon from your root config file. And it can be as simple as a component, or it can be a full-blown application. In reality, your parcels should be more or less coming from different frameworks. An example, if you use the same framework, which we do here, I apologize, you should probably use different frameworks, because if you use the same one, you should probably use the exported components function, because it makes it much more lightweight to work in this way. So maybe to show you more in the code how this works, let's jump maybe to see the breakdown. So as I mentioned, we have a root application, which is this Space Explorer single SPA. In it, as I mentioned, we have a index.html file, which provides a couple of things. First off, which is important, we use system.js to load our dependencies. Do you see it correctly? You should. Okay. And in it, in the import map, you will see a couple of things. Initially, you will see that we import our applications. We also import our parcels. And we import some shared dependencies. Now we preload some of this data. Again, this is quite bootstrapped. And at the end, we come to the more important part. And this is the basic purpose of a root application, which loads and registers a single SPA application. So for an application to be registered, you need to call it based on, you need to give it a name, you need to call based on its import, which we defined earlier, and you need to provide an activity function. So meaning where this single page application will be shown. So this one will be shown on every route, while the space application will be shown only on the space route. So that means it won't use anything in your browser until it reaches that point. So coming maybe to the next concept that we mentioned, which was an application. In this case, we have 2 of them. One is the Space Explorer, and the other one is Space. So in the Space Explorer, I'm going to show you the configuration is the same for the other one. You need to provide a couple of things that application can be recognized and that it can properly work. So you have also some utility files that single SPA provides that can help you bootstrap these things quickly. But you need to provide the following functions. In all cases, application needs to have a bootstrap function. It needs to have a mount function and an unmount function. There is also an unload, which is an optional one. We didn't use it in this case. We didn't find it quite useful to show you anything with it. What is important about these functions is they all need to be asynchronous, meaning they should always return a promise that your single SPA knows how to properly handle them. So the last concept that we mentioned is the concept of parcels. So as I mentioned, parcel can be as big as an application or as small as a component. In our case, let's take the Saturn one. This one is at the size of the application. So by its nature, the way you declare a parcel, it's the same as you would declare an application. You again need to provide a couple of lifecycle functions. You have a bootstrap, you have mount, and you have unmount. These look a bit more complex. They're just adding logs that I will use later to elaborate a bit how the application works. So again, it should always return a promise. And unlike how we declare the application in the root config, we specifically mount this one on demand. So you can see in example here, we first need to, how do you mount a parcel? You need to define a slot where you want to have it, and you need to call, now we're in the Space Explorer application, just if I skipped the step, sorry. So in here, we want to call on the mount. During the mount process, we want to mount a component. For it, we need to get that DOM element. And we need to provide to the mount parcel function which parcel we would like to load and in which area of the code we would like to show it. And with this, I will hand over to James to maybe continue talking about the communication.
Cool. So yeah, let's just go through a quick reminder of some of the, thank you, cool, of those main concepts and what's important for us. So there are obviously other benefits, but what's really important for us. So first one we're going to look at is loose coupling, the application being isolated and controlling communications between micro applications. So the general concept, yes, we should have things as isolated as possible, but we also want to have good user experience. So there has to be some sharing of contextual data in the UI. So each micro app knows, for example, which filters are applied or if a button has been clicked, etc. So we're looking at how we can control that. So single SPA has a few recommendations of how you could approach this. First one is to export some functions from your micro app, or micro front end, I should say. For us, we've avoided this approach. The reason is because we feel it kind of exposes some of the internals of your micro front end that we really want to avoid doing. And you could potentially have some issues in your application, some runtime errors in your app, if the signature of your exported function changes. So if you change the name of it or change some of the parameters that you expect, it could cause issues in the application which is integrating your micro app, micro front end. Second possibility, second recommendation from single SPA is to use cross micro front end imports. So let's say a similar concept to the first one, but in this case, it's kind of a shared library. So for all of your different micro apps, you have a shared library exporting some utility functions to let you do things like manage authentication between applications. And again, for us, at least in this fundamental thing we're trying to achieve of just sharing some UI state or some simple actions, it's a bit too complex and results in some coupling that we want to avoid. So in addition to the fact that you could have some issues if your signatures change, if function signatures change, if you make a change to a micro app which impacts one of the signatures, you have to republish the micro-frontend, the shared library, and then anything using that shared library. So you're kind of increasing the complexity of having, you're moving away from that concept of independent deployments, which is so important to us. So the one that we chose and what we'll focus on, and Nikola will show in detail, is to use event emitters. So essentially kind of a pub-sub model to emit some events which micro-frontends can choose to listen to. They can listen to them, they can ignore them, they can reject them potentially. So for us, it's really the preferred approach and what we are using for sharing simple UI states. It avoids some runtime errors that could occur if you're, like we talked about with function signatures changing. And it has to be done in a controlled way, but for us, your worst case is that if something changes and your application is not listening to the correct event, you might be looking at potentially the wrong view or the wrong filter within the application. So you have to do this really with care, so you know that you're not going to accidentally show some completely incorrect data for something critical that users need to see. But for us, it's kind of a safe way to keep it simple and avoid those runtime errors, but still keeping some control. And it's you.
Thank you. So for the coding demo, let's maybe first take a look how this is implemented in the UI. So what we're going to show you now is the space view. I'm just waiting for this to blink a bit. So as I mentioned earlier, this is composed out of two micro-frontends. You can also see it here on the right side. You have two applications that are currently in the mounted state, one being the space application, the one that you see as a content, and the Space Explorer one. So Space Explorer is consisted out of this navbar that you see at the top and this button Deploy Astronaut in the bottom, well, for me, left corner. So what we did is we're going to emit an event from the Space Explorer component. And if I clear this a bit, you will see how it goes. So from the application Space Explorer, we're deploying an astronaut, and the components, or another application Space, is at this moment handling this event. And you could have seen that we triggered a UI change where the astronaut just moved and came closer to you guys. So how is this implemented? Let's maybe quickly see it in the component here. So in the application Space Explorer, the main one where the button is located, like I said, there is nothing special here. You just have one button which has on-click event, it emits on-click event deploy astronaut, which basically is a new custom event. We can use the regular events. We just use this one because we want to provide some contextual data to the other component. And the one thing that you can notice here is that we're providing two things. In this case, we're providing the name and surname of an astronaut, while in the console log, we just caught the name, meaning that the contract isn't actually respected, and it's more of a problem that also James will jump into a bit later. And I can show you a bit how it works on the space component, where in its application, basically, there is nothing happening except when the component is mounted, it adds an event listener, it listens for the same event, and from the detail, which we emitted there, is just passing in the name, which we're just logging, and we just set the state that, okay, at this moment, the astronaut is deployed and you cannot deploy it anymore. So maybe back to James to talk a bit more on the next steps for communication.
Cool, thanks. So yeah, as we mentioned, we've used event emitters as a lightweight and it's a scalable solution as well. So we're using browser events. So any application which is integrated can listen for those browser events or not, depending on how the app is designed. And for us, it's really the best way to avoid coupling between front ends. that's kind of opinionated. So obviously there are other ways in the single SPA documentation. There are other ways that you could imagine, but for us, it's one that works. The drawback for our current implementation of this is that there's no built-in contracts of what events you should be sending, and no real built-in validation, so that you obviously saw a very naive version of it where this poor astronaut is just deployed when someone randomly clicks a button without any kind of safety checking. And yeah, this for us is kind of a drawback. So as some next steps that we're looking at, first one is looking at how we can export a types library so we know, so we can essentially define a contract for the messages that a specific application expects to receive. So as I'll say parent app, but an application which is integrating several micro-frontends could have a documented, recorded way of knowing that they're sending the expected messages or broadcasting the expected messages. The second one, as I said, it was a naive implementation of it, but what we want to do is have a really robust way of validating that the incoming messages are valid. And this is actually the more important side of it. It's inside the micro-frontend, validating really strictly that the message I've received is a valid one. It's, I don't know, the parameters are as expected, the data structure is expected, or the values which are given are within the range that I expect within the application. So this is the key area that we're focusing on now. And the final one that we didn't mention, but is a little bit of a change from what we've been saying, is so far we're talking only about event emitters, but what we're looking at is how we can use URL parameters for filtering, because the URL parameters are accessible to all micro apps, and it's probably a better pattern for us to use, but we're not using it yet. So something that we are exploring. So next concept, we already looked at composability. So how do I, sorry, you have a question? Go ahead.
A couple of questions actually. How does the bumps up model avoids a runtime issue? The event and the triggering and the listing happens at runtime?
Not without validation and contract in place. It won't avoid it completely. So it avoids it in a sense. If your parent application starts emitting some event and you don't subscribe to it, you won't have any runtime issues. But if you subscribe to the same event and you expect something that you don't get, or you get something completely different, you're going to have it. So this is what James explained. So for the next steps, we need to have some contracts in place between the micro-frontends that are going to be shared among the teams, so as an interface of communication between them and how they're going to integrate one with another.
How do you create a shared event bus between every micro-frontend component if you have different framework, or even in the same framework? I do not understand how is the event bus created.
We're going to talk more about the team topologies a bit later in the presentation, if this is...
Is your question about team structure or about the technical implementation of the browser events?
How is an event from a package, let's say an NPM package, emitted, and another NPM package is being listening to it? How is the event bus created so that they can actually publish and subscribe to the events?
So this is where the root application comes into place. Everything is coupled together there, so everything is bundled. So when you emit an event, it's a native browser implementation. So at this moment, you emit event to the whole, everybody who listens to it. Doesn't matter in which application is it a React, or is it a Vue, is it Angular? If it subscribes to a specific global event listener, so the one that you have at the window, you're going to catch the event. So you can have multiple subscribers in this case even.
Because I was concerned about the concurrency. If two concurrent actions cause the triggering of the event, then if the browser's issue handle it and not the application.
Yes.
Thank you.
No worries.
Cool. Good questions. Thank you. So yeah, composability. So this is the concept of being able to assemble small micro front ends into a larger application. And I don't have very much to say on it because it's all in the demo.
Yeah. Okay, so the next thing that we're going to take a look into is the parcels. So the thing that you could have seen earlier is when we mount this, you can see that the application, once this page is loaded, as I said, this has 3 micro frontends running. Well, at this moment, only 2. One being the Space Explorer. And you can see also, maybe looking back, that the space is not mounted here. That means that it's not accessible at this route. And here, where the crew manifest is not mounted, we're imperatively going to call it now. So we want to call upon the crew manifest to appear. And you can see that the event was the mount function was called from the Space Explorer micro frontend, and the parcel crew manifest caught it and finished the mounting. So with this, let me show you maybe how the code looks like for the mounting of the. Sorry, 1 second. It's in the Space Explorer one. Here we have on the. Oh, sorry, wrong component. Here we have a button, like I said, that has a button pressed. It follows the same logic. Basically, on button pressed, we're going to either, depending if the component is mounted, we're either going to mount it or unmount it. Mount, it's the same as I described earlier for the one in the parcel Saturn. So you can see that we need to provide the DOM element where it's going to render. We provide a function that imports it, and we send the DOM element. And we update the crew manifest state at this moment. For the unmount, you will notice that during the mount, we store this in a local variable. And if you want to unmount it, you can call upon it, you can just call upon the function unmount, which again, it should be a promise. It returns it returns just true or false. The component is then unmounted, its lifecycle is updated, and we update the crew manifest state. The implementation you saw earlier, again, it's the same one as in the parcel Saturn. We have just a bootstrap function, mount and unmount, so nothing spectacular is happening on the parcel that you haven't seen so far. So coming back to the presentation, is why are parcels important to us? Okay, so parcels, as you could have seen, we composed a UI, which was a dashboard. Okay, and it was composed out of various elements. In our case, we used Vue for all examples. In reality, you shouldn't do that. You should have one, maybe if it comes from React, the other one from Angular, maybe third one from Vue. But as James said, probably shouldn't mix and match so many things. But as you can imagine, at Sanofi, it's a corporation quite large in its size with multiple development departments, and we have a diverse portfolio of applications where each web application can use a different framework. And as you can imagine, we're present on the market for quite some time, so we had a couple of evolutionary steps which we need to integrate together. We need to refactor some things. In our department, primarily we work mostly with React and Vue, but I can swear that we don't have anything else in our portfolio. And as you could have seen earlier when James was showing, we have a functionality overlap between the applications where different business cases have been resolved multiple times by different teams, and basically creating a variation in the user experience for the same subset of data or same subset of services. So the teams unintentionally created functionality duplication and in some cases even code duplication. So as we had some experience with working in microservices and creating some, let's call it business data sets, so we already separated our data, we separated our backend services, we restructured the way we work, but the only thing that remained was these monolithic front ends. So in order, you cannot just say, let's use parcels and everything is going to be magical. We had to restructure our teams a bit. So we created something like a pod-like structure. where we had enabling teams working mostly on these, I apologize, transversal applications like micro apps like we saw here, or like this Saturn or a crew manifest, which you can import in multiple applications that would use it, be it a GXP or non-GXP alike. And we had the product teams mostly focused on the business value, so delivering business products to our customers, and they were responsible for integration and domain-specific functionality. So the two teams just had to interact with each other. So for this, we just composed some interfaces where one is providing to another, okay, this is what this is what we delivered, this is how you can integrate it, and as James said, we're now exploring the ways how we can document this more in a better way. So far, we're mostly on a, I don't want to say paper-based, but Confluence-based documentation in this case. And maybe jumping to the next step, which is being independently deployable. And I think this is the part which is mostly interesting to everybody working in a validated environment. So what does this mean? Micro-frontends, by default, benefit from being independently deployable. You can easily migrate, you can easily experiment with it. And we're going to talk in this section a bit more about how we can independently deploy components and how we can share dependencies between the components. So let me show you a quick demo on how this works. Let's jump briefly into our browser, and let's take a look back into the Space Explorer page, where, as you could have seen in the extension that I use, we have two micro-frontends, Space and Space Explorer. At this moment, they are both mounted. And in our root configuration, we just declared them. So the application running on port 3000 is our root app. So you will see that nothing changes here. The time is still the same. But let me just quickly deploy an updated version of Space Updated, which is running on a different port. Let me quickly copy it. Okay. And we can, in a development environment, quickly override the Space. And if I'm not mistaken, it's JS app.js. So here we have a red rocket, and now we want to just apply override. And without even changing the root application, you just independently deployed a new Space application, something changed below it. So at this point, you can imagine that the Space application was GXP, it went through all its quality processes, you have every following documentation, but the UX for the users changed without any deploy being changed on the root config or on the Space Explorer application. So maybe this was an ugly demo, so let me show you in a bit different way. Let's clean this up and return it to the initial state. And let's just jump back into the terminal and quickly kill this one. And I'm going to kill the main Space application. And I'm just going to readjust the port so that you see of a Space updated. So you're going to see that nothing changes except the port where it listens. And I'm going to redeploy just this one. It should run on port 8083 now. Yes, I hope it's visible. And if we take a look here, it should refresh. If you take a look here, now we have, again, completely independently deployed. So you have the same URL, nothing changed, but a completely different application running under the hood. And this is actually the main benefit that we want to present to you. And this is how we solve this, let's call it a big issue of how to accelerate our delivery in a sense of a regulated environment. So next topic here that I mentioned briefly was shared dependencies. So if you remember when I talked about the root configuration, in the index.html, we had a couple of things which we shared, and we imported with System.js. We called upon a single SPA, Vue, and Vue router, and we provide them to all applications. So to configure it, you just import it, and in applications where you want to use it, you just need to configure your Webpack that it uses externals, which are Vue and Vue router. So to be honest, You can, and you don't have to use shared dependencies. We find it quite useful that we use it, especially since we reduce the overhead of loading same things multiple times over time. This way we increase the performance. And I don't know if I have, no, yeah, that's on the shared dependencies. Again, if you have different frameworks, maybe you want to add also React, but as a good rule of thumb, I would say you should try to just load large dependencies and share them, while the smaller ones you can probably load at the level of the application. So why do we find independent deploys so good to us? Well, they're easy, they're quick to set up, they work by default, they allow us to share the dependencies between the application. And one thing that we haven't touched so far, and it's quite important from the quality perspective, and that's testing. So with this, we keep the testing capabilities of each micro app to the team, or micro-frontend application, to each team that develops this one. So at this moment, you only unit test, test integration, you test the end-to-end at the level of the application that you're developing. And at the moment when you integrate it, you only test the integration between those two applications. You don't have to retest the behavior of the application below it, the one that's integrated in it. And I'm going to hand over to James.
Thank you. So yeah, a quick wrap up of looking at what we've seen and some additional problems and challenges that we've had. So maybe to summarize, it is a really nice approach in our context. It's working and it has helped us to improve some processes, but it's definitely not without its challenges. So a few of those, so things we didn't already talk about. First one, I think, is the learning curve. So for developers. So first of all, understanding the concepts of single spar or generally micro-frontends, the overall overarching principles. It took a little bit longer than we expected for everyone to, ourselves included, and we're still learning, but for everyone to understand those general principles before getting to the point of being able to actually go ahead with the technical implementation. And then when you get to the technical implementation, it's a little bit more tricky to get started than we had anticipated. So if you're going to go with this approach, make sure that people are in an environment where they have time to learn those things, where they don't have the pressure to deliver something really critical in this manner. It's really important. And probably choose something with a really small scope that's lightweight and non-critical to try with this approach first. So that leads us on to the next point about restructuring existing projects. So it's taken us some time, even though we defined the approach, the theory is really nice, everyone agrees with it. It takes some time to make sure the micro front ends are actually integrated and replacing that functionality that we're trying to replace. So yeah, again, do this progressively, try and choose something simple first so you can really prove the value and demonstrate the concept to everybody, and prove that it's worth doing. The next point, so Nikola touched on this, is something where I'd say we haven't got to where we want to be yet. So it's a work in progress, but is around restructuring teams to fit this model. So we had obviously come from that model where we had what we refer to as pods, teams working on big monolithic front ends, accidentally duplicating pieces of code between them. And that requires some carve out, so into what Nikola, I think, referred to as enabler teams and product teams. So where the enabler team is working on the smaller components that could be shared, and the product team is more of an integration team, and then working on some of the business or domain specific code. This, yeah, as with any team restructure, takes time, needs to be thought out, and it's one of the challenges and something that's ongoing for us. And then the final one, which is probably the biggest challenge for us, and one where you need to, throughout this whole journey, keep your QA team or whoever the people are who are helping you with those documentation processes, the administrative processes, they need to understand what it is that you're doing. So make sure that you've shared the concept with them. Make sure you take the time to explain fully what it is that you're trying to achieve, how it's going to streamline the process, and fundamentally make sure that once you've implemented the micro-frontend, that you're also removing some administration and documentation from other parts of the process. So you're not just adding a new technology, you have to remove some of the overhead at the same time. And so that's really working so closely with the QA team it's a fundamental thing. A quick reminder, just to finish, of some of the guiding principles that we touched on. So remember the mission. So the mission for us was to reduce the administrative overhead, increase agility for regulated app development and deployment. So help us to move faster. So some of those principles. So the micro-frontend is an independent application, and it has to be treated in that way in terms of your technical processes, but more importantly for us, in terms of your administrative processes. So smaller releases with a smaller scope and documentation covering that scope, not the scope of an entire monolithic application. Communication, so this is referring back to the loose coupling communication between apps. So event communication works really well for us, but you must have strict validation, which we are, like we said, are not where we want to be yet. And most importantly, keep it simple. So try not to have, or let's say, avoid tight integration between each part of the app, because it will just become overly complex. You'll introduce tight coupling, and in many cases, it's probably not necessary. Dependency sharing is really nice, nice feature to reduce the size of your download, but make sure that you have a clear testing strategy so that you can prove to an auditor or justify to your QA team that we can have these shared dependencies because we know, thanks to our automated testing strategy, that we're not going to break anything. And final point, as with the previous slide, is about the team. So really follow that microservice principle, actually, of having a team for your microservice, have a team for your micro-frontend app. Don't try to have, or at least this didn't work for us, don't try to have bigger product teams working on the product and then also working on some independent micro-frontends. Really try and carve out those. For us, it's these two concepts. Probably will be organization dependent, but think through the team, take the time to think about how you want to change things, and also you can experiment over time. You probably won't get that structure right the first time. And with that, just a couple of links to share. So first one is the GitHub repo that for the code Nikola shared, and the second one is a link to the SingleSpar website. And thank you very much, and we have some time for questions if you have any.
Go ahead.
Yeah, I was wondering if you have sort of this component that you load a second component. Do you have a way for those two components to interact? So you sort of load this component instead of another. It sort of have an implication on the first component, or do you keep the concerns completely separate?
We try to keep the concerns as separate as possible, because this way, if you just tie the communication across, so one component triggers another, you could easily create a logic that you don't want to have at this moment. So you would tightly couple things, you would expose the knowledge of a root application to the subset of applications that compose it. So we find it as an anti-pattern in this sense, if I understood the question correctly.
You understood correctly.
Yeah.
Yes.
Go ahead.
If I understand, then if you have one product,
full micro apps. A badly behaved micro app could, in theory, mess with the whole DOM, right? It's all on that page. So do you actually avoid the need to regression test the product when you release a micro app? It seems like from the regulated environment, there's still the risk that you could blow up the entire product when one enablement team releases this stuff. So do you assume that your CI/CD and the practices prevent that, and then it still allows you to do these dependencies, or is there something else?
Do you want to take it? Or?
You hit the nail on the head with the CI/CD processes. So yeah, the critical thing is making sure that you do have some, let's say, I don't know, integration or end-to-end tests which are in place, which allow you to make sure you're not going to release something which is going to crash everything. But the point is that those are executed automatically, but they're not considered as a change to the parent or that integrating app. So it's more in releasing my micro app, I will automatically trigger this test suite. But I'm not going to have to go through all of the administrative overhead of doing 2 separate releases or 2 separate test suite executions.
The test suite includes products that use that app.
Yeah. Is that?
Yep.
Yeah.
Major updates of the shared dependencies, and let's say that one micro front-end is used in several applications, and now one of the application wants for some reason to upgrade. I mean, it depends.
You mean like Vue? Okay. So
Micro changes, and all of a sudden you see you find yourself having to upgrade each and every app using a certain micro front-end of one app.
So for this, we have a pattern that we use. So in majority of cases, we have a standardized things. So we have a certain version of Vue that we use for us. But in reality, how it works, majority of your applications, at least for us, are running on the same version. So we keep this one as a shared dependency. And of course, it's possible that one of your products is going to evolve. In example, this whole repo is written with Vue 2. Maybe somebody wants to use a composition API and switch to Vue 3. You can do that. You just don't configure your Webpack to take the shared dependency. It rather uses the view from below. It can even use React. So like I said, in this example, we just stick with Vue, but you can have as many dependencies. They can be shared or they don't have to be. We just follow the practice that we share the dependency that's used by majority of the applications that we have. So if at one point Vue 3 becomes the dominant one, only then we would update the root configuration that we share the dependency of Vue 3. Until this happens, we share the Vue 2. Well, with a specific micro-frontend, yes. Unfortunately, it's unavoidable. But the same can be said that you load also React and Vue and Angular at some point. So it's simply unavoidable, and this is exactly why we want to use this one.
The shared dependencies automatically understood by the single spot, or do you have to manually include it in the root?
So in the root config, you need to import the ones that you want to use. So this is the one that's going to declare for every micro frontend or every parcel that you want to use there. You need to define it. But on the level of the application, you need to configure, or each micro frontend, you need to configure a Webpack. Do you want to use this shared dependency, or if you want to use the one that you have?
In terms of team structure, which team is responsible for the root content? Does this
Well, in reality, once you start building micro frontends, you need to have root config per each project. So you need to have, for each of these applications, if you want to independently deploy it, you need to have a root config that's going to deploy it. So everybody is responsible for the one that their application uses. So maybe you're going to have multiple applications, and you will be responsible for that one.
So the integrating app is the one that's going to manage the root config, and that will say, okay, I need to import micro frontend X, Y, and Z, and that they will manage that root config.
Exactly. Go ahead.
I was wondering what's been most difficult for you to this project?
Sure. Let's see if we both have the same answer. For me, we talked about learning curve and things, but for us, it's the problem we're trying to focus on and highlight in this presentation for us is how do we streamline the process? And it's making sure that people really understand the concept and accept that if we implement this, the deal is that you help us to streamline the process behind it. And so that's always, you know, within Sanofi people, we have really very good relationships between dev and QA teams, but it always takes time for people to understand the concept and figure out, okay, that means we can take this approach in the documentation or this approach in the release. So that for me is probably the biggest challenge of getting that message through and getting it widespread and understood and accepted enough to be taken on board.
And maybe to rephrase this, it's always easier to explain this concept to technical personnel working on implementing this rather than quality personnel that doesn't have a technical background in this sense. So this was the most difficult part, to change the processes within and make it widespread. So we're running also some internal presentations trying to educate people on how this can help us accelerate our development processes.
Save the money.
Save the money. Be the leader.
We missed that one, and it's probably going in the next slide. I think we've run out of time. I want to say thank you so much to everyone for coming. We hope you took something from the presentation. So thanks a lot, guys.
Thank you, everybody.